Okay, this video is going to go over how to transform a state space model to a transfer function. So for a state space to transfer function, we can take any linear time invariant state space model, either a nonlinear system that's been linearized or an already linear state space model, and get a transfer function or a set of transfer functions from it. So for our general solution, we have our typical linear state space model. This one is naturally linear. We're going to apply a Laplace transform to it. So our derivative is going to be replaced by s times x of s. And for this case, I left out the initial conditions here. A little x vector is going to be replaced by big X vector. Little u is replaced by big U. And now we shift over this x over here and combine them together. Now S is implicitly multiplied by our identity matrix here, so we can group them together like this. And then now all we need to do is just solve for x of s in this case. So we end up just taking the inverse of this giant matrix right here, giving us this thing here, times b times u. Now for y, all we need to do is plug in that solution for x. So all we do is we plug in for this little x here, it'll be this Laplace transform, this guy right here, multiplied by c plus d times u. And then if we divide by u, we get the way to get a transfer function from any state space model. And you can see that these are actually vectors, implying that if you have multiple inputs or multiple outputs, you can actually have multiple transfer functions that would all together describe different inputs or outputs for the system. And that covers how to get a state space model to turn into a transfer function.